क्या आप आईएएस की तैयारी कर रहे हैं और कोचिंग इंस्टीट्यूट्स को 2.5 लाख तक की फीस नहीं पे करना चाहते? अगर हाँ, तो 22,500 रुपए में घर बैठ के StudyIQ के पेनड्राइव कोर्स के साथ आप आईएएस की तैयारी कर सकते हैं। आज ही विजिट करें StudyIQ.com।
Hello friends, welcome to StudyIQ. In this session, we are going to start with a fresh series, fresh topic, that is probability. Okay, so very important topic, we all know, right? And slightly difficult topic for some of you at least. So we'll try to handle this topic in a complete way. So what we will do is we'll start with the basics. Okay, we'll try to understand the terminologies. I am taking this session with the view or with the assumption that even the freshers are attending the session. So those people who might have forgotten those maths basics, even I'm considering those people also. So I'm starting with the very basics. I'll start with experiments. I tell you what are the different types of experiments. We'll talk about sample space, we'll talk about elementary events, we'll talk about events and all these associated concepts. Then only I'll move on to the actual or the formal session on probability like we used to take in CAT or any other particular exam. Okay, so first one or two sessions will be for basics. So those who are very thorough with the basics, one or two sessions is not important for you. Okay, now we all know life is full of chances. Even your selection in your competitive exam is also based on chances, and those chances is what we are going to understand in this particular session. Okay, so we need to start with the basics. So let me start off with this particular word, experiment. You will come across this word a lot when we discuss about probability or the questions related to probability. So what do you mean by experiment? Experiment is any operation or activity performed under certain condition. So these are the 2 points which is again important that you need to note down here. Any operation or activity performed under certain condition, and also which will give you a well defined, you will see different words like outcomes, results, etc. So let me write it as outcomes. So you'll see results also. So these are the 3 words. An operation you are performing under certain conditions and which is giving outcomes. Now if you ask me, there are 2 types of experiments. Okay, so one is deterministic experiment. Deterministic experiment means the outcomes are predicted. Okay, so like you can predict the outcomes, so that is what deterministic. Whereas the other one, that is probabilistic, and this is what we are interested in this particular chapter, probabilistic or random. So as its name indicate, you might have understood that the outcomes are not predicted. These are random outcomes. You don't know, right? For example, you can toss a coin, you don't know what is going to come. I'm talking about an unbiased coin. Okay, if it's a biased coin, if it is so designed that it will always come as head as the outcome, that's a different case. I'm talking about unbiased coin or unbiased die. If you throw, you don't know what is going to come, right? So those experiments is what we call as probabilistic experiment, and you can come across all these examples like tossing a coin, rolling a die in your questions. Okay, so that's what probabilistic experiment or random experiment. Now when we talk about random experiment, again 2 important words or the points that you need to remember or understand clearly is, you will come across elementary events. Okay, I'll explain it in detail. Elementary events or simple events, or simply you will get outcome. Okay, so what is this elementary events or simple events? See, this is nothing but when you are performing any random experiment, okay, or you are performing any probabilistic experiment, the outcome which is going to come, or each outcome, okay, each outcome produced is called as elementary event. Okay, so each outcome is which is produced in this random experiment is called as elementary event. Okay, so then another point that we need to know is sample space. So what is sample space? Sample space is actually the all possible outcomes. Okay, so I hope you understood what is elementary event. in a random experiment which is performed, each outcome produced is called as an elementary event, okay, which is associated to that experiment. See, it's like when you're tossing a coin, each outcome means it can be head or tail, okay. So getting a head, which is an elementary event, getting a tail, which is also an elementary event. So there are two elementary events. What is sample space? Sample space then means all possible outcomes, which is head and a tail. So I hope you understood the difference. So elementary event means each outcome which is possible. So when you're rolling a die, getting 1, getting 2, getting 3, getting 4, getting 5, getting 6 are different outcomes, right? So first outcome, which is getting 1, that is elementary event 1. Similarly, getting 2, elementary event 2. So there are 6 elementary events. Similarly, all these outcomes, if you club together, like 1, 2, 3, 4, 5, 6, this is your sample space. So this two has to be clear for you, elementary event and sample space, okay. So if you want to formally understand this, or if you need to note down this, if there are events like this, okay, so E1, E2, E3, etc. up to En, possible outcomes are there, we call these as elementary events, okay. So E1, E2, E3 up to En are elementary events, and when you write all these together, E1, E2, etc. up to En, this is called the sample space. So the set of all outcomes are called as sample space. Each outcome we can understand as elementary events. Now from this sample space, if you consider the subsets of the sample space, okay, we'll discuss the concepts of subset more when we discuss about sets and Venn diagram. So if you take the subsets, the singleton subsets, okay, singleton subsets means one element. It can be E1, then E2, etc. up to En. So from the sample space, when you consider the subsets of the sample space, the subsets which is singleton subsets, okay, or singleton sets are actually the elementary events. That is what this E1, E2, E3 up to N. I hope you understood, okay. So if you extend this, if you are rolling a die, elementary event 1, what is that? Getting 1. Elementary event 2, that is getting 2. So what is E3? That is getting 3. So on, and E6, which is getting 6. So there are 6 elementary events. So if you ask me what is the sample space, sample space will be E1, E2, E3, E4, E5, E6. What is E1? Getting 1. E2? Getting 2. Okay, so all these are the possible outcomes. I hope it is clear for you. So let me make this concepts clear. Now if you are tossing a coin, what is the sample space? HT. Okay, so tossing coin, the sample space is HT. Rolling a die, it is 1, 2, 3, 4, 5, 6. Okay, so here you are rolling a die. Now you are tossing 2 coins. See, you will get questions like 2 coins are tossed simultaneously, or the very same coin is tossed twice. Okay, both are same. 2 coins are tossing simultaneously and the same coin is tossing twice. A coin is tossed twice. Both are having same meaning. So either I'll write a coin tossed twice, or 2 coins are tossed simultaneously, or just tossing 2 coins. What are the possible outcomes? Each outcome is elementary event, and clubbing all the elementary event, you will get the set. Okay, so what will be the sample space? It can be HH, you will get both heads, or you can get both tails, or in the first toss you will get a head and the second toss you will get a tail, or in the first toss you will get a tail and in the second toss you will get a head. So this is your sample space, because 4 outcomes are there, and each of this outcome is what we call as elementary events. So I hope this concept is clear for all of you. Now next, let's take a case of rolling 2 dice. So we already understood tossing 1 coin, rolling a die, then tossing 2 coins. Then let's see rolling 2 dice. Then we'll go for tossing 3 coins and rolling 3 dice, and that's it. Okay, with that the basics will be clear. All these things should be there at your fingertips, because there is no need to imagine or no need to think about all these possibilities during the time of exam. Before exam itself, these things should be there in your hand. Okay, so if you're rolling 2 die, okay, so let's roll this 2 dice. Okay, now this is your side which we are looking for. Okay, so, or the top. Okay, now what number is coming here is what we are actually going to search. So what are the possibilities? See, this can be a case of rolling 2 dice simultaneously or 1 die twice. So starting with 1, what are the possibilities? This will give you outcome from 1 to 6. This will also give you outcome from 1 to 6. Okay, so sample space of this is 1, 2, 3, 4, 5, 6. This is also 1, 2, 3, 4, 5, 6. When you're rolling it together, see, the possible outcomes are, the first one will give you 1, second one will also give you 1, first one will give you 1, second one will give you 2. Then we keep the first one as 1 itself. 3, 1, 4, 1, 5, 1, 6. Now, this is not the end, right? Similarly, 2, 1, 2, 2, we keep 2 and we vary the second one, okay? Now, 3, 1, 3, 2 and so on. Similarly, 4, 1, 4, 2 and so on. 5, 1, 5, 2 and so on. 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. Okay, so these are the possible outcomes which you are going to get when you are rolling a die. So you can clearly see there are 36 total outcomes possible. So there are 36 elementary events possible for this experiment, and this sample space contains 36 possibilities. All the possible outcomes are there in the sample space. Okay, so 36 elementary events, which when you are writing in the set form, it will become your sample space. So you can write this as E11. Okay, getting elementary event of getting 1 and 1. This is E12. This is E13. This is E14. Like that. This is E21, E22. So this is E66. So E11, E12, E13, etc., up to E66, that is your sample space. So if you define your sample space, see, you can write like this. You can write E11, E12, E13, etc., up to E66. So it contains 36 elements, and it is very difficult task to write. We know the easier method, that is a set builder form, to represent this. If you can observe some pattern here. So what is a pattern which is observed here? See, this these values, if you are saying ij, if you take it as exy or eij, where I varies from 1 to 6, right? So you can write I between 1 to 6, j also between 1 to 6, right? So I and j both varies between 1 to 6. So how will you write this in a set builder form? You can write S is equal to, either S is equal to like this, that is the normal form, right? So that is the roster form in which you can explain this. Set builder form you can write in this way: I comma j, okay, where I varies from, or I is between 1 to 6, okay, then j is also between 1 to 6. So this is how you will write in a set builder form. So this is your roster form. If you want, you can write it as eij, okay, because we have done in the same way. Or you can simply write here 1 1 1 2 1 3, like that also, that's fine. So here you just need to write ij. Okay, so that's your set builder form. This is how you'll represent the sample space. Now let's take another case where you are tossing 3 coins. Okay, so when you're tossing 3 coins, what are the outcomes possible? Let's take this as coin 1, coin 2, coin 3. Okay, so what is the first elementary event, or what is the first outcome which is possible? You can get H, 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 all are head. So what is E2? E2 will be H, H, T. You got one tail. Similarly, E3 will be H, T, H. Here also one tail, but second coin is giving you the tail. Now, what is the next possibility? H, T, T. Both are tail now. Okay. Then what else is possible? All are tail. Then you can see this possibility: tail, head, tail. Then tail, tail, head. Then T, H, H. Okay. So if you count here, observe here: 1, 2, 3, 4, 5, 6, 7, 8. There are 8 possibilities. So these are your elementary events. So this is E3, E4, E5, E6, E7, E8. So E1 is getting all heads, so that is your this thing. Okay, so then you can write the sample space as in the set E1, E2, E3, etc. like this. So this is your sample space. You need to write this completely. Okay, so when you're writing this, you should write H, comma, H, T, comma, H, T, comma, H, T, comma, T, comma, T, and T, H. I hope I have covered all 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is your sample space, and each of these outcomes are your elementary events. So keep this in your mind all the time. We need to use it directly. So if you can keep this as ready-made answer with you, that is going to be very helpful. Okay, now next important point that we need to understand is events. Okay, so you already understood what are elementary events. You already understood what is the sample space. What is events? See, elementary event is also an event, but the point is, see, all the elementary events are events, but all events are not elementary events. That means there are more events apart from elementary events. So if you take the set of events, elementary events will come as part of it. Okay, but there are some other events also. So what are those events? That's what we need to understand, because this is going to be very useful, or this concept is going to be very important in your future sessions. Okay, so let's try to understand this. See, if you take the case of tossing a coin, what is the sample space? HT. Okay, what is the sample space? HT. These are the two possible outcomes. So sample space is all the possible outcomes. What is elementary event? Elementary event, we know this is H and this is T. We already told that the singleton subset is the elementary event. Now, what is event if you ask me? See, events are nothing but the subset. Okay, so subset of sample space. Events are nothing but the subset of sample space. So what is the sample space? Sample space is this HT. So what are the subsets? See, for any set, phi is a subset, which is the null set. Okay, then so that is the first subset. Then the second one, that set in itself is a set, okay, subset. Okay, so H comma T, this is a set, or this is a subset. Then third subset, which is the singleton set, that is H, and fourth will be T. So these are the four subsets of this set. And what is that set? That is the sample space. So if you take the subset of the sample space, in this case, since there are two items are there in the sample space, we are getting four subsets, and we know how you are getting this. This is nothing but 2 raised to 2. Number of subsets which are available will be depending on this number. If that is 2, 2 raised to 2. If there are 3 numbers, 2 raised to 3. This concept we have discussed when we discussed about permutation combination. Okay, so here you can see 4 subsets, and all these are called as events. So this is what events, out of which you can see clearly these two are elementary events. These two are elementary events. Okay, so this is how you need to understand now. Elementary events is this part only, then events is this. So all elementary events are events, but not all events are elementary events. So this is how you need to understand that. Now let's take one more example. Once we understood about the coin, let's take the case of rolling a die. What are the possible outcomes? 1, 2, 3, 4, 5, 6. And this is what we call a sample space. And if we take each element from the sample space, we call it as elementary event. That's what we understood till now. What we understood now, when we say events, what do you mean by events? Events are all the possible subsets of this. And how many subsets are possible? 2 raised to 6, which is nothing but 64. So if you ask me how many events are there for this sample space, there are 64 events are there, out of which we understood that there are 6 elementary events. What are they? The singleton subsets. Okay, so 1, 2, 3, 4, 5, 6. What are they? These are elementary events. So events are 64. Out of 64, 6 are elementary events. That's how you need to interpret. So total subsets is 64. Now phi, which is a null set, which is also a subset, and 1, 2, 3, 4, 5, 6, that's a set in itself, which is also a subset. Okay, now let's try to understand different events. Let's define few events. Event A. Event A means, if I tell you getting an even number on the die. So what are the events possible? It can be 2, 4, 6. So this is one event. Okay, so if I define B, so event B as getting odd number when you roll the die, 1, 3, 5. Okay, similarly C, there is no specific description, so I give you something like 1, 2, 6. Here you can't find any specific description, like here 2 are even and 1 is odd. There is nothing which you can generalize. So let's take this even D. You can see here 3, 4, 5, 6, because obviously this is going to be a subset, right? So how can you define this event? This event is nothing but getting a number which is greater than 2, okay, or greater than or equal to 3. Okay, so in both way you can interpret this, getting an even greater than 2 or greater than or equal to 3, 4, 5, 6. Okay, so that's how different events you can understand from the given sample space. So there are 64 subsets are possible. For each subset you can define an event. Okay, so each subsets are different events, and singleton subsets are what we call as the elementary events. Okay, so other events you can define based on the condition, or based on the definition you need to pick up those favorable events. Okay, so see, if I am saying that event A, which is getting an even number, then what are the favorable event, or what are the favorable outcome? 2, 4, 6. This is how you'll write. Or if I say event C or event D is getting a number which is greater than 2, then what are the favorable outcome? 3, 4, 5, 6. So this is what we call as the favorable outcome. Okay, so these are what we call as the favorable outcome. Okay, now let's take the case of tossing 3 coins. So we already saw when tossing 3 coins, we have the sample space like H, 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 T, H, T, H, H, T, 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 H, T, 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 H, T, H, H. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. So these are the possible outcomes. All these are called as elementary events if you take independently. HHH if you take independently, this is elementary event. HHT if you take independently, that is elementary event. Okay, all these are elementary events. Now, what are the possible outcomes or other outcomes which we can qualify as events? So what do you mean by events? You can see here, what is the cardinality of this set? Cardinality means number of elements. Okay, so you will represent like this. Let's suppose sample space is represented as S. Cardinality of S you can write as 8. Okay, now what do you mean by power set? Power set is nothing but set of all sets, and that's what we are discussing as events, right? We were actually taking out the set of all sets, or all the possible sets which you can make from this set. Like you can combine this 2, you can combine this 3, you can combine this 3, like that. Okay, all the possible sets you can make. So that is what power set. And we have seen power set is nothing but all the subsets of this set. So how many subsets are possible? We understood that 2 raised to 8. Okay, so 2 raised to 8 which is equal to 256 subsets are possible. So if you mention power set like this, P of S, the cardinality of P of S, because you will write a subset like this only. So if you are writing HT in the previous case, this is a sample space. So each event are like this 5, then H comma T, that is another subset. H is one subset, T is one subset. These two are elementary events. Now if you are writing the power set means set of all of this. So set of all the subsets, that means 5, then H, then T, then H comma T. So this is your power set. So power set is nothing but which contain all the events. Okay, so if you need to know how many events are there, you need to see the cardinality or number of elements in the power set, which is nothing but the number of subsets, which is nothing but 256 in this case, which is 2 raised to 8. Okay, so you can clearly see here subsets of sample space is what given here. And what is power set? Power set is the set of all the subsets. which is what you have written here. And how will you get the number of that? 2 raised to n. That's how you got here. And you represent like this, power set. So events, this is nothing but events only. The cardinality of power set is nothing but the number of events only. So power set means all the possible events. So what are they? Now if you observe this 256 events, out of which 8 are elementary, which we clearly know these are the 8 events which is actually there in the sample space. These are elementary events, that means singleton set or singleton subsets are elementary events. So 8 elementary events. Then one we know, that is 5, okay, which is a null set. Okay, then we know the set of the sample space itself is a subset. Okay, so already 10 events we clearly know. These are the 10 events which we know. Now other events we can define. So let's take this case, getting exactly 2 heads. Okay, see if you observe here, getting exactly 2 heads, exactly 2 heads, that is your event A. So I define my event A as getting exactly 2 heads. So now we need to look at this sets and we need to see what are the elementary events which are favorable to this event. Okay, so what are the elementary events which are favorable to event A? So getting exactly 2 heads, here you can see, here you can see, and here you can see. So you can clearly see HHT, HTH and THH. Okay, so these are the elementary events which is favorable to event A. So elementary events means these single events. So we need to observe in the sample space and we need to see which elementary events favorable to the defined event. Or if I tell you, let me discuss this case, event B. Let me define like this, getting number of heads more than number of tails. Okay, so number of heads greater than number of tails. So my event B is defined like this, number of heads should be more than number of tails. So what we need to do now, look at the sample space and see which are the elementary events which are favorable to event B. So this is event B. Event B is defined like this. So we need to look at the sample space and see in the elementary events which are the elementary events which are favorable to event B. So number of heads should be greater than number of tails. So this is satisfying because 3 heads, no tails. So that is one case. So you can write firstly H, then this, okay, obviously 2 heads are there. This also 2 heads are there. This is not, this is not, this is not, this is not, this also 2 heads. So HHT, HTH, THH. So these are the favorable elementary events to event B. Okay. Now if you say getting at least 1 head, getting at least 1 head. So what are the elementary events which are favorable? You can get 1 head here, you can get 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 here, except this, all will come in this set. Okay, so there are 7 elementary events. There are 7 elementary events. So if C is getting at least 1 head, there are 7 elementary events which are favorable to event C. Okay, now one point which you can see here is this set which you got, this is a subset, okay, or which belongs to, this is a symbol of subset. Okay, so this is a subset of the sample space. Here also you can see this is also a subset of sample space. This is also going to be a subset of sample space.
क्या आप IAS की तैयारी कर रहे हैं और कोचिंग इंस्टीट्यूट्स को 2.5 लाख तक की फीस नहीं पे करना चाहते? अगर हाँ, तो 22,500 रुपए में घर बैठ के StudyIQ के पेन ड्राइव कोर्स के साथ आप IAS की तैयारी कर सकते हैं। आज ही विजिट करें StudyIQ.com।